Simplifying fractions using prime factorization. Prime numbers are 2, 3, 5, 7, 11, and they keep going, but these are the first ones. So you're going to take 16 22nds, and instead of doing greatest common factor or least common multiple, you're going to just use prime factorization. You're going to ask yourself if they're both divisible by 2. And to be divisible by 2, this last number has to be a 0, 2, 4, 6, 8, or 10. And these two are. So half of 16 is 8. Half of 6, you can cut these two in half, but if you don't know, you can cut this one in half and this one in half and add them together. Half of 10 is 5, and half of 6 is 3, and 5 and 3 is 8. Okay, half of 22, half of 2 is 1, half of 2 is 1, so this is the answer. And this number is prime, and that's how I know when to stop. The next one is 12 16ths. Yes, you can cut it by 4, but if you're using prime factorization, you're going to cut it by 2 first because they're both divisible by 2. And you're going to say half of 12, half of 10 is 5, half of 2 is 1, 5 and 1 is 6. Half of 10 is 5, half of 6 is 3, 5 and 3 is 8. And then you're going to go back. Is this one divisible by 2? Yes, it's divisible by 2. Half of 6 is 3. Half of 8 is 4. And 3 is a prime number. That's how you know you're done. 18/30, half of 10 is 5. Half of 8 is 4. 5 and 4 is 9. Half of 30 is 15. Think about a clock. This one, are they both divisible by 2? The answer is no. So you're going to go to 3. Are they both divisible by 3? The answer is yes. 9 divided by 3 is 3. And 15 divided by 3 is 5. And 3 and 5 are both prime, and that's how you know when to stop. 36 28ths. Yes, you can convert it to, this is an improper fraction. Yes, you can convert it to a mixed number, but you should convert it to a mixed number at the end because smaller numbers are easier to work with. First, you're going to use prime factorization to see if they're both divisible by 2. They are. Half of 30 is 15. Half of 6 is 3. 15 and 3 is 18. Then we're going to cut this one in half. Half of 8 is 4. Half of 2 is 1. 18/14. Half of 10 is 5. Half of 8 is 4. 5 and 4 is 9. Half of 10 is 5. Half of 4 is 2. 5 and 2 is 7. This one I can do that. Okay, and that's going to give me the right answer, and I'll show you how to do that way in a second. This one, I can just look at it and I can see if I have 9 sevenths, 7 sevenths gives me 1 whole, and I need to figure out how many sevenths I need to get to 9 sevenths. 7, 8, 9, 2 sevenths. So this is 1 whole and 2 sevenths. If I do it this way, 7 goes into 9. This is the exact same thing. 7 goes into 9 one time. 7 times 1 is 7. 9 minus 7 is 2. So 9 and 7 can't go in there anymore. So this is where I get this. This goes here. My 1, I pulled it out 1 time. This is telling me I pulled out 1 whole, 7 sevenths 1 time, and I have 2 left over. 15/45. Are they both divisible by 2? No. Are they both divisible by 3? Yes. Because 5 plus 1 is 6, and 4 plus 5 is 9. That's not how you simplify. That's just saying if these two numbers add up to a number that's divisible by 3, then this number is divisible by 3. And 6 is divisible by 3, and 9 is divisible by 3. So these two numbers can be divided by 3. I can divide them by 3, or I can divide them by 5. Either way would be correct. So if I want to do it by 3, 15 divided by 3 is 5, and 45 divided by 3, if I think about a clock, I have 15, 30, 45. I have 3 15s here. And 5 and these two end in 5. Are they both divisible by 2? No. Are they both divisible by 3? No. Are they both divisible by 5? Yes. 5 divided by 5 is 1. 15 divided by 5 is 3. The answer is 1/3.